This problem gives us a sign convention for the current at node A. This sign convention is arbitrary, but I have to stick with it when I define any current named I. So I want to find this current positive into the terminal A for these four cases. For part A, 2 amps is entering node A. So I have 2 amps positive in this direction. I is defined positive entering node A. These 2 arrows are in the same direction, so I don't need to change the sign on this number, and I is positive 2 amps. For part B, 3 amps is leaving node A. So let's redraw the circuit with the correct current. We have 3 amps leaving node A. To determine I, we have to stick with this sign convention for I. So I is positive entering node A. These 2 arrows are in opposite directions, so I have to change the sign on I, so I is equal to negative 3 amps for this case. For part C, I know that negative 4 amps is entering node B. So I have current entering node B, and it's negative 4 amps. My circuit elements can't absorb charge, so any current entering the element has to be balanced by an equal current leaving the element. So I have negative 4 amps leaving node A. To convert that for a number for I have to take into account I's sign convention. I is positive entering node A. This arrow is in the opposite direction as this arrow, so I have to change the sign on I. So I is the negative of negative 4 amps, and I in this case is positive 4 amps. Finally, for part D, I have 5 amps leaving node B. So 5 amps is leaving node B. Since I can't accumulate charge, that has to be balanced with 5 amps entering node A. I is positive entering node A. This arrow and this arrow are in the same direction, so I is positive 5 amps in this case.